Hello everybody, this is section 9.6, solving systems with Gaussian elimination. So we're back to solving systems of equations, and we're going to use matrices to do it. There's actually three different ways that we're going to use matrices to solve systems, and the first is with this Gaussian elimination. And the way we're going to do this is we're going to turn our systems of equations into augmented matrices. Alright, so basically an augmented matrix just takes every number or every coefficient and every constant that's in our system and turns it into a number in a matrix. So for example, if we have 2x plus y equals 5 and negative 4x plus 6y equals 12, we just take each of those coefficients and constants and put them directly into a matrix. A lot of times you will see a dotted line, a vertical dotted line, that would appear right here between kind of where the equal sign was in the system. Sometimes you'll see like a little dotted line right there, but I don't have a good way to put that into my slides. So, for example number one, we're going to take the system here. We're going to write the augmented matrix that corresponds to it. So I'm not going to switch to the document camera for this example or the next because I think these are probably easy enough. If you want to hit pause, give yourself a chance to try to write the augmented matrix, and then I'll just put the answer on the screen. So if you want to do that, pause now. Alright, here's our answer, which the 2x minus y plus 1 is 2, negative 1, 1, and then we see that all three of these equal 0, so you can see the zeros in the right hand column. And yeah, so on and so forth. So I think this is a pretty straightforward exercise. Our second example is just going in the opposite direction. So starting with this matrix that has 3 rows and 4 columns, we will turn it into an x, y, and z 3-variable system. So once again, if you want to pause for a moment and try to write that out, and then I will reveal the answer on the slide. So if you want to do that, pause now. Alright, here's our solution to this example. 3x minus y minus z equals 7. 2x plus 2z equals 8, and y plus z equals 0. Alright, so the way we're going to solve these systems is with something called row operations. Basically, just like when we're doing elimination on the 3-variable systems directly, we can interchange rows, we can multiply by non-zero constants to basically just change the values in a row. And then we can add and subtract rows to one another and replace a row with the result. So there's a little notation that we use here to kind of indicate what we're doing to each row and what row we're going to insert our answer into. So if you see a capital R, that'll represent the new row. Like that's what's going to go into the new row. And then if it's R1, that'll be the first row, R2 would be the second row, etc. And then if you see lowercase letters, R1, R2, R3, that means we're taking what is currently there in row 1 or row 2 or row 3, and we're going to do some math with it, and then we'll store our answer in whatever the capital letter R is. So here's an example for how we're going to do row operations. See, this one says we want to take negative 3 times row 1 plus row 2, and whatever that gives us, we will stick it into R2, row 2, in the new matrix that we're going to create. Alright, so we'll switch over to the document camera to do this one. I think this is a good one to work out by hand. In example number 3, we are just trying to complete some row operations. So we're going to multiply row 1 by negative 3. That'll give us negative 3, 6, and negative 6. And then we're going to add that to row 2. And that'll give us a 0, a 1, and a 3. So that's our new row 2. We're going to rewrite our matrix, leaving row 1 as it was, and putting this new solution into row 2. So that's our final answer right there for this particular set of row operations. Alright, so the whole point of this is to try to get augmented matrices into what we call row echelon form. Echelon is just kind of a fancy word for rank. So this is kind of like ranked rows, where the first row you'll see has all 4 entries in it. Possibly there could be some zeros in there, but we see that the very first entry in the very first row is a 1, and everything beneath that is a 0. Okay, and then we see that in the second row, the second entry is a 1, and everything below that is a 0, and so on and so forth. So typically that means you're going to end up with this diagonal of 1s that starts in the top left and goes down to the bottom, toward the bottom right, and everything below that diagonal is going to be a 0. Okay, so what happens is we get the matrix into this form, and then we can do back substitution to solve for each of the variables, because typically that third row that's 0, 0, 1, and in here I just have an f to represent some constant, that row is basically saying z equals f, whatever f is. Okay, and then we could take that and plug it in, so we'd have d times whatever f is plus 1y would equal e on the second row, and so on and so forth. We just basically back substitute, work our way up the matrix. All right, so I have an example here that we're going to do. And we'll start by writing this system of equations as an augmented matrix. So I'm going to go ahead and do that before we switch over to the document camera, and then I'll show you how we're going to work out our matrix into row echelon form. Okay, this will be our augmented matrix for this system. So let's switch over to the document camera now, and I'll show you how we're going to do this. We're going to use the calculator to give us a little bit of a boost. All right, for example number 4, we're wanting to solve the system of equations using this augmented matrix. And we just did an example in number 3 where we did some row operations in order to, well, we were told what to do on the last one, but if you noticed, it created a 0 in the first entry of the second row, okay, getting us a little bit closer to row echelon form. And in fact, I think that answer was in row echelon form. But the row operations themselves are not that much different from just solving a system of equations using elimination. And so personally, I feel like the biggest advantage of a matrix is that we can use the calculator to do a lot of this for us. So hopefully you guys will be able to see my screen well enough to kind of keep up with what I'm doing. The first thing is to enter this matrix into the calculator. So the matrix menu is found here on the x to the negative 1 button. That's the inverse key. So if we hit second inverse, that brings up the matrix menu, and the first thing we need to do is we need to put the matrix into the calculator. So we have to go over to the edit menu, and then we'll hit enter on matrix A. We have to tell it what size matrix we want. So this is a 3-row 4-column matrix, so we put in 3, enter, 4, enter, and now we have all of the spaces that we need in order to enter this matrix. So 2, and after you type in the numbers, just like when you put stuff into the data lists, you type the number, hit enter, and it goes to the next spot. So 2, 2, 0, and then the 6. The second row is all 1s, so we'll put all 1s in there. Then the third row is 3, 4, negative 1, 13. All right, so the next thing I'm going to do is really important, and I strongly encourage you to do this. Okay, I'm going to hit second quit to go back to the home screen, and then I'm going to go back to the matrix menu, and I'm just going to select matrix A, and I'm going to hit enter. And I want to make sure that the matrix that's in my calculator is exactly the same as the matrix that I intended to put in my calculator. So again, hopefully you guys can read my screen well enough that the resolution's high enough. But this matrix is an exact match of what I wanted. So now I'm going to go back to the matrix menu again. This time I'm going to go over to this math menu. And I'm going to scroll down until I see REF. Okay, that stands for row echelon form. So I hit enter on REF, and then I have to tell it which matrix I want to put in row echelon form. So I go back to the matrix menu again, I select matrix A, and then we can close that parentheses, and hit enter. Okay, so not uncommon to get some ugly decimals in here. What I would encourage you to do is to hit math frac, so that instead of looking at ugly decimals, we can look at less ugly fractions. Alright, so now we're going to go back to our pen and paper, or pencil and paper, whatever you may be using. So 1 4/3, negative 1/3, 13/3. Okay, there's our first row, and then we have 0, 1, negative 1, 4, and 0, 0, 1, negative 2. Okay, so this is our, we can put our calculators away for a moment. This is our our row echelon form augmented matrix. So right off the bat, this row right here tells us that z equals negative 2. All right. So now the second row here says that y minus z equals 4. So I can put negative 2 in for z. Y minus negative 2 equals 4. That tells me y plus 2 is 4, or y is 2. Okay. So now I have two variables. I know y is 2 and z is negative 2. So I can go to my third equation, the first line of the matrix, but the third equation we're going to use. This is going to be x plus 4/3 times y, which is 2, minus 1/3 times z, which is negative 2, and that should equal 13/3. All right, so a little bit of algebra to do here. X plus 8/3, that should be plus 2/3 equals 13/3. So 8/3 and 2/3 is 10/3, which if I subtract 10, well, let's do it in two steps. X plus 10/3 equals 13/3. And then if I subtract 10/3 from both sides, we see that 13/3 minus 10/3 is 3/3, or just 1. So our final solution to this system of equations is the ordered triple 1, 2, negative 2. And there's our solution. So again, like I said, I think the most valuable part of solving a system of equations using an augmented matrix is that we have the calculator functions that will help us to do the sort of the tedious math, and then we can take it from there to back substitute to get the values for our variables. All right, so that's everything that you need for Gaussian elimination. Basically, you have to write systems as augmented matrices. You need to be able to go backwards and write augmented matrices as systems of equations. And then we need to use Gaussian elimination and some back substitution to solve systems of equations. All right, so good luck on this. Please send me an email if you have a question about something, and I will talk to you guys soon.